Hello to everyone, welcome back to my YouTube channel Jeet Academy. In this particular video, I'll be solving paper October-November 2024 and the variant is 1-3. Alright, so let's start. So the first question over here came from sequence and series. So let's read it. An arithmetic progression has fourth term. So I could highlight this as 15 and eighth term is 25. It says find the 30th term of the progression, right? Okay. So in an arithmetic progression, we know that the general term is given by an is equal to a plus n minus 1 times d, where d is the common difference. And therefore, fourth term, right? So a4 would be what? It would be simply 4 minus 1, that is 3d. And that is given to us as 15. So we get this as equation 1. And we are given with the eighth term, which is, a8, a plus 7d is equal to 25. All right. So now what I can do is I can call this as equation 1 and this as equation 2. So we get two simultaneous equations and two unknowns are there, isn't it? So writing this equation one below the other and solving for a and d. So this turns out to be a plus 3d, which is equal to 15. So now subtract, so sign will change. And therefore we get a and a cancels out. 7 minus 3 turns out to be 4d equal to 25 minus 15 is 10. And therefore d is equal to 10 over 4, which is 5 over 2. Okay. Now, once we know d, I need to find the value of a. Therefore, putting the value of d equal to 5 by 2 in the first equation, put in equation 1, and we get a plus 3 times 5 over 2 is equal to 15. And therefore, we get a is equal to 15 minus 15 over 2, right? 3 times 5 is 15. So 15 over 2, when I transpose this to right hand side, it comes in negative, right? So taking the LCM here, 2 times 15 is 30 minus 15, which is nothing but 15 over 2. Okay, so we have a and we got the value of d as well. Now we need to compute the value of a 30, right? So 30th term of the progression. So simple. Therefore, a 30 would be what? It would be a plus 29d and a is 15 over 2 plus 29 times 5 over 2. Okay, so this simply gets added 15 plus 29 times 5. So 30 times 5 is basically 150. So this becomes 145 and the LCM is 2 itself. So this becomes 160 over 2, which is nothing but 80. Okay, so finally we get the 30th term as 80. So that's our answer. Okay, basic question. Now, moving on to the next one, belongs to trigonometry, I guess. Yeah. Find the exact solution. So exact is important, of the equation cos of so and so equal to 0 for the constraints. I mean, the domain is from negative pi over 4 to positive pi over 4, and this is the equation we have. So let's first define the domain over here. So we call this as 0, and this is your 45 degree pi by 4. All right. And that's your negative pi by 4. So clockwise direction is negative. Okay. So now it says cos of pi over 6. So let me convert this into degrees, which is basically 30 degrees, plus tan 2x plus root 3 over 2 equal to 0. Now, cos 30 is basically equal to sin 60, which is nothing but root 3 over 2 plus tan 2x root 3 over 2 equal to 0. So we get tan of 2x plus root 3 over 2 plus root 3 over 2 eventually will give you root 3 equal to 0. And therefore, I get tan 2x is equal to negative root 3, right? So now what we see here is the angle over here is 2x, isn't it? And the domain which is given to us is for x. So what I need to do here, so 2x will go from, just multiply throughout by 2. So negative pi by 2 to positive pi by 2. Okay, so that means first quadrant and the second quadrant, isn't it? Now tan of some angle is negative basically. So where tan is negative? Tan is negative in the second quadrant as well as in the fourth quadrant, isn't it? But now see, will the domain go to second quadrant? No, right? So I have no solution over here because my domain is defined only for the first quadrant and the fourth quadrant. This is the fourth quadrant, isn't it? So I'll get only one solution, which is this. Getting it? So now I can say tan inverse of, you just find the principal value over here. So principal value 2x is equal to tan inverse of root 3. Forget about this negative. Negative only tells us that the solution is in, it is not in first and third quadrant because tan is positive. So over here, now tan inverse of this is 60 degrees. So we basically get pi over 3. Okay, 2x. So 2x value is pi over 3. Now what I need to find is, we have to find the value of x, not 2x. Okay, now can pi by 3 be the answer over here for 2x? Yes, because for 2x, the domain goes from minus 90 to plus 90, isn't it? 2x domain goes from where? Complete fourth quadrant and the first quadrant, is it? Yes, therefore x is equal to how much? Pi over 6. Is this thing clear? Yeah. Okay. So pi over 6 is basically 30 degrees, right? But then at pi over 6, it is positive, isn't it? So is pi over 6 the correct answer? No, it's negative over here, isn't it? So this is what you need to keep in mind. Purposely I've written this because, most of the students, they do this. They forget about the negative sign, isn't it? So pi by 6 is basically 30, which is in the first quadrant, and tan is positive in the first quadrant, isn't it? So I need my solution here in the fourth quadrant. Getting it? So this is what the concept is. So what I'll do basically, so I know that it is negative, right? So pi by 3 in the, I can directly move in the clockwise direction. So therefore, instead of this angle, this is my principal value. So I shouldn't take this because this lies in the first quadrant. I hope you understood the concept here. Okay. So 2x rather should be negative pi by 3. It should be negative 60. Getting it? So this lies in the fourth quadrant because my tan 2x is negative here, right? This thing. I have to focus on this. So we got the principal value. So you get this basically 360 minus I have to do to get in the fourth quadrant. But then since the domain is allowed from minus pi by 2 to pi by 2, right? So how do I get into minus pi by 2? This is negative pi by 2. So from 0, I have to move in the clockwise direction. So I can move 60 degrees, right? Clockwise, which is nothing but negative this thing. So basically x is equal to what? Negative pi over 6. And this is my only solution. Okay. I hope the concept is clear. All right. So since it was for negative, mind it, we have to use it for the negative. Okay. Now moving on to the next question. Okay. So next question belongs from binomial. So it says find the coefficient of x cubed, all right, and x to the power 4 in the expansion of this, where a is a constant. Give your answer in terms of a. Okay, a is a constant. All right then. So let's try to open this. So basically here, my a is 3 and the b is ax, right? So how do I write it? I'll start with 5c0 in the expansion of this. First term, which is basically 3, 5 minus 0, and then we get negative ax, whole thing to the power 0, plus 5c1, 3 to the power 5 minus 1, negative ax to the power 1, plus 5c2, 3 to the power 5 minus 2. So that's 5 minus 2. Okay. And then negative ax, whole thing to the power 2. And then plus 5c3. So this becomes 3 to the power 5 minus 3 and negative ax to the power 3. Okay. And I need to find x power 4. So plus 5c4, 3 to the power 5 minus 4, negative ax to the power of 4. Okay. Now, where do I see the cube term? So here is the cubic term and here is the biquadratic term, right? X to the power 4. So coefficient of x to the power 3 is basically 5c3 3 raised to 5 minus 3 is 2. Negative a to the 3 is negative a raised to power 3 times x cube. All right. And let me do a partition here. For x to the power 4, we get 5c4, 3 to the power 1, negative a to the power 4 times x to the power 4. And therefore, if I'll talk about the coefficient of x cube, so that's 5c3. So 5c3 turns out to be 5 factorial, 5 was a 20 over 2, right? That's 10 times 9 times negative a cube, right? So negative will be outside times x cube. So this becomes negative 90 a cube. So that's the answer for the coefficient of x cube. 5c4 is 5 itself times 3. Negative a to positive power, that means even power, will eventually give you positive a, and this becomes 15a to the power 4. Got it? So these are the coefficients of x cube and x to the power 4. I hope it is clear to you. Now, coming on to the next bit of it. Given that the coefficient of x power 4 in the expansion of this is 240, find the positive value of a. So let me highlight what they have asked. The coefficient of x to the power 4, which we already found over here. So let me highlight this as well. Okay. Perfect. So now, in the expansion of this is 240. Okay, so this is given to us. So now we have to think when we will get x to the power 4, right? So this concept I have already explained you in the previous paper when I was doing. So let me explain it once more. So the concept goes like this: ax plus 7. When you multiply this with the expansion of 3 minus ax to the power 7, right? So ax, the x times the cubic term in this, right? The cubic term in this multiplied by ax, getting it, will eventually give you a term in x to the power 4. And so I'm explaining you the concept here. Think plus 7 multiplied by the x to the power 4 term, right, will also give you x to the power 4, right? So we will get basically two terms when we expand this in x to the power 4, right? So that is cubic, right? So what is the cubic term which we have already found, right? So they will give you the question, the sub part of it, so that it will be related to the previous part. Okay. All right. So we already know that the coefficient of x cube term, what was the x cube term from the previous one? It was negative 90a cubed, right? Multiplied by x cube. And what is the ax term? Ax is this multiplied by this. All right. Plus, because plus 7 is here, right? Plus 7 is here. So plus 7 times the x power 4 term over here. So what is x power 4 term? We get 15a power 4, 15a to the power 4 multiplied by x power 4. So this is what we will get when we expand this. Okay, so x times x will give you x to the power 4, negative 90 as it is. A cube times a is a to the power 4 plus 105 a to the power 4 x to the power 4. Right, so now these are like terms. So 105 minus 90 will give you 15 a4 multiplied by x to the power 4. Now what is given? It's given that the coefficient of x to the power 4 is how much? That's given to us as 240. Therefore, 15 a raised to 4 should be equal to 240, or a raised to 4 should be equal to 240 over 15, right? So which eventually becomes, so I could cancel with 3, 80 over 5, which becomes 16. So we get a equal to positive 2 and we get a equal to negative 2, right? So let's read the question once more. Find the positive value of a. So clearly they have mentioned a is positive and therefore a is equal to 2. That's the solution and we will neglect this. Okay, I hope this is clear to you. Now, moving on to the next question. The fourth one, it says solve the equation 4 sine power 4 theta plus 2 sine square theta minus 7 equal to 0 for the domain 0 to 360. Okay, so let's highlight what is given to us. This is the equation given to us. and this is the domain of the theta lies from 0 to 360, and 0 and 360 being inclusive. So that means my solution will lie in all the four quadrants. That is what is given to us. 0 starts from here, goes till 90, 180, 270, and 360. This is the first thing you need to do to define the quadrants and the domain. Okay, all right. Now, so it's a biquadratic. I cannot solve this using the calculator as well. So therefore, I have to go for the complex quadratic reduction. So how can I reduce this to a proper quadratic? So we'll do some assumption. Let's assume that t is equal to sine square theta. Okay. Therefore, can I simply say this becomes sine square theta whole square? Can I write 4 as square and square, right? Because power to the power gets multiplied, plus 12 sine square theta minus 7 equal to 0. Now we have already assumed that t is equal to sine square theta. So this becomes 4t square plus 12t minus 7 is equal to 0, isn't it? So sine square and the whole thing squared, and assuming sine square as some variable, okay? Or you can say instead of t, it could be y, it could be x or anything. All right. So now we need to solve. Now negative 7 times 4 is basically, negative 28. So two numbers whose product is negative 28 and the sum is 12. So that's basically what? Plus 14 and minus 2. Okay. So if I'll solve this, I'll basically get this equation. Are you getting this? Okay. So you could also do this way. I can split the middle term as positive 14t minus 2t minus 7 equal to 0. And then 2t taking common, I'll get t plus 7, 2t plus 7 actually. And then 2t plus 7, repeat the brackets, minus 1 outside. And therefore we get 2t minus 1 times 2t plus 7 is equal to 0. And therefore I get the value of t as 1 over 2. And I get the value of t as negative 7 over 2. All right. Now, are these the solutions? No. Let's come back to what we had assumed. We had assumed t is equal to sine square theta, and therefore substituting it back, sine square theta is equal to 1 over 2. And from here, I get sine square theta is equal to negative 7 over 2. Now, you only think LHS, right? This is always positive. It's a square. Square of any number, can it be negative? That's always positive, and this is always negative. So no solution. Okay. So the reason being square of any number, positive or negative, is always positive. So negative 7 by 2 is negative, which is not possible. So no solution. And therefore, we get the solutions from here. So sine theta is equal to plus minus under root of 1 over 2. Okay. So we get here sine theta is equal to 1 over root 2. And we get from here sine theta is equal to negative 1 over root 2. So basically, now sine is positive in which two quadrants? Sine theta is equal to this, right? So principal value from here is what? Theta is equal to sine inverse of 1 over root 2, which is 45 degrees. Okay, so that's theta 1 in the first quadrant. Sine is positive in first quadrant and the second quadrant. So how do I get into second quadrant? 180 minus 45, right? So theta 2 value will be how much? Theta 2 would be 180 minus 45, which is nothing but 135 degrees. Okay, so we get these two solutions. Now, negative. Okay, so you don't have to do anything. So theta 3. Where is sine negative? Sine is negative, so let me use a different color. So sine is negative in the third quadrant. So this will become 180 plus principal value. Okay, so principal value we already found, it's 45 in the first quadrant. So this becomes 225. Okay, and theta 4 would be in the fourth quadrant. So that's 360 minus principal value. Okay, so you don't have to solve the sine theta equal to negative 1 over root 2 again and again, because 1 over root 2 and 1 over root 2 are one and the same thing. So principal value remains same for both. So this becomes eventually 360 minus 40 is 320 minus 5, 315 degrees. So final answer is what? 45 degrees, 135 degrees, 225 degrees, and we get 315 degrees. So these are the four solutions which we will get for this equation, and it makes sense also, right? It's a biquadratic. Yes or no? Biquadratic means what? Biquadratic means x power is 1. Okay. X, sorry, the power is 4 basically. So technically I should have 4 roots at the most. And we got 4 roots for this equation, right? So this makes sense. All right, moving on to the next one. So here we have the fifth question, which is based on transformation of functions. So let's see this. In the diagram, the graph with equation y equal to f of x is shown with solid lines, and the graph with equation y equal to g of x is shown with broken lines. Okay. Describe fully a sequence of 3 transformations which transforms the graph of y equal to f of x to the graph of y equal to g of x. All right, so here we'll try to look at the intuition behind this, how we can generate the shape, right? So one more easy thing is you can always mark the points. It gives you a rough idea, okay, how the transformation is. So this point is basically 1, 1. This point is 2, 1. This point is 4, 2. Right. Now, when we see these points, right, this is negative 1, comma 6. This is negative 2, 2. This is negative 3, 2. And this becomes negative 5, 4. Right. So as I can see here, the important, what do you call, observation, what we can see here is, here the y coordinates are 1, 1, 3, 2. Okay. But here it becomes 2, 2, 4, 6. So that means clearly my y is becoming 2y. Okay. And the shape also, if you'll see, it has been, overturned, or you can say it's a reflection about the y-axis, right? Because it is facing this side. So this length is basically facing towards this end. Okay, so there is a reflection also about the y-axis that is involved. So now once we know these points, I can quickly erase them. Now, how do you proceed after knowing that there is a reflection, right? So this point will remain same as it is, it will not change. And this point, which is 1, comma 1, will become negative 1, comma 1. Okay, so you could join like this. And then this goes up to one line here. And then this goes till here. Okay, so this is what the shape is after reflection about the y-axis. Okay, so I could write clearly my first set of transformation is reflection about the y-axis. Okay, because x, all the x is becoming negative x, and the y remains the same, and that further being transformed, right? So now I need to figure out this thing is translated. Can you see this? Now this generated shape is getting translated to this shape over here, right? So it has moved towards left hand side, right? And that is by how many units? So I could quickly write the x coordinates of this, which is 0, 3. That's negative 1, 1. That's negative 2, 1. And that is negative 4, 2. All right. So now what we see over here. So now let me write the final answer. That is basically the coordinates of, the now vector by which it has been translated upwards, or you can say left hand side and upwards as well. Okay, so if I'll see the x coordinate of this final graph, that is basically negative 5, only the x coordinate I'm putting, and this becomes negative 3, this becomes negative 2, right, and this becomes negative 1. All right, so what I see is, just look at the x coordinates here. That's negative 1, right? That's 0. Here it is negative 2. Here it is negative 4. So negative 4 becomes negative 5. Negative 2 becomes negative 3. Negative 1 becomes negative 2. And 0 becomes negative 1, right? So it is moving towards left by a vector of -1, isn't it? So reflection about the y-axis means here I can interpret x becomes negative x. All right. And then the second thing is translation. Okay. We are translating it by the vector -1, 0. Right? It is moving towards left. And it is moving towards left by 1 unit. Right? So I'll put minus sign over here. Is that thing clear? Yeah. So reflection, and then we have a translation by the vector -1, 0. This is what we have seen. So now let me erase the information which is not required. Okay, so this is how we get the intuition of the new points. Now we see that every x has been shifted towards left after reflection about y-axis. Now I need to write the y values, right? So here the y value is basically 6, and this point is -2, 2. This point is -3, 2, and this point is -5, 4. Right? So here it was how much? This was 1, 1. This is 2, 1. This is 4, 1. And this is 0, 3. Right? So you check here, all the y values are getting multiplied by 2, and therefore 3 times 2 becomes 6. Isn't it? So 0, 3 becomes basically -1, 6. Right? So now the third transformation is basically, you can say a vertical stretch, isn't it? You can say a vertical stretch. You can write vertical stretch by a factor of 2, parallel to y-axis. Okay. So these are the transformations which are happening over here. Got it? So this is how you need to write it. I hope it makes sense. Now, the second question is, find an expression for g of x, okay, in the form of a times f of b of x plus c, where a, b, c are the integers. So the same transformations, I need to put it in the form of an equation. So how it will look like? So we know that reflection about the y-axis means x becomes, so first transformation is, let's suppose if it is y equal to a times f of bx plus c. So here the first transformation is the reflection. That means x will become negative x, right? Let a be as it is. X will become negative x, okay, plus c. So first transformation is done. All right. Now, what we have to do is, we have to write here a value, right? So that was basically what? A vertical stretch factor of 2, isn't it? So this becomes 2. 2 times -x plus c. Now what is this x plus c? It is moving towards left, isn't it? So minus 1, translation by a vector of -1. So how do we write it? So we write it like this, twice of f of x minus of minus will become plus, and therefore when I open this, you'll get 2 times f of -x minus 1. Got it? So if it goes towards left, we are getting this as minus, because there is a reflection about the y-axis. So minus x plus 1. Got it? Yes. So x plus 1 I need to write, because it is moving towards left hand side. Right? So it is contrary to the common sense, and this is what we have learned as well. Okay. Suppose we have a graph which is basically y equal to x squared, right? Then a graph y equal to x minus 2, or x plus 2 rather, right, is a graph which is moving towards left hand side by 2 units. This is the graph passing through the origin. So x plus 2 means moving towards left, isn't it? So we have to write plus here, x plus 1. And then this minus is for the reflection. So reflection happens to the entire x plus 1. Right? Then therefore we get -x, -1. So this is your final answer. I hope it is clear to you. Okay. Don't write -x plus 1. Okay. It is this reflection, basically translation is happening on x and not on negative x. I hope this thing is clear to you. Okay, so be careful over here. Now coming on to the next question, which is the sixth one. The first term of a convergent geometric progression is 10. So here the convergent geometric progression is 10. So this is very, very important. Convergent series, when a GP will converge, when the common ratio is basically lesser than 1, right? Then what it says the sum of the first 4 terms of the progression is P, right? The sum of the first 4 terms, and the sum of the first 8 terms of the progression is Q. It is given that P over Q is equal to 17 over 16. Okay, find the two possible values of the sum to infinity. All right, so we know that since it's given R is lesser than 1, and the first term of the convergent series GP is 10, basically the sum of the first 4 terms of the progression is P. So S4 is equal to A times R to the power 4. Right, it's convergent, so basically I should write 1 minus, right, 1 minus R to the power 4 over 1 minus R, and N is equal to 4, so A is 10, 1 minus R to the power 4 over 1 minus R, that's equation 1. And then we are given with the sum of the first 8 terms. All right, so how do you write sum of 8 terms? Same formula. A is 10, 1 minus R to the power 8 over 1 minus R, and that becomes your second equation. All right, now these things are given to us as P and Q, isn't it? So basically I can write them down. So this guy is basically equal to P, and this guy is equal to Q. Okay, so now it is given that Q is to P. So if I divide Q with P, so I'll get 10, 1 minus R to the power 8 over 1 minus R, whole thing over 10 over 1 minus R to the power 4, 1 over. So 10 and 10 cancels out, 1 minus R cancels out. So we are left out with 1 minus R to the power 8 over 1 minus R to the power 4. Now I could write this 1 minus R to the power 8 as R power 4 whole squared, right? Power to the power gets multiplied, so 4 times 2 is 8 over 1 minus R to the power 4. Now 1 can be written as 1 square, right? So this is A square minus B square identity we got over here. So we could simplify it easily, since A squared minus B squared is equal to A plus B times A minus B. That is how we factorize it. So we have to look for this Q over P, which is equal to 17 over 16. And P over Q, we got it from here as, so I can write it as 1 minus R power 4 times 1 plus R to the power 4, whole thing over 1 minus R to the power 4. Okay, that is the reason I've written it like this, so that we can cancel out the common factors over here. Then we have over 16, or I could say R to the power 4 is 17 over 16 minus 1, which basically turns out to be 17 minus 16 over 16. That is R to the power 4. Now R is equal to 1 over 16, right? With a plus minus the fourth root of it. Therefore, we get R is equal to 1 over 2, or we get negative 2, right? So we got two values of R. Now they're asking us to find the sum of the possible values of the sum to infinity. So what is the formula for sum to infinity basically? All right. So sum to infinity for case 1, when R is equal to 1 by 2, sum to infinity formula is A over 1 minus R. So A here is 10. R we got it as 1 by 2. So this becomes 10 over 1 by 2, which is equal to 20. So the first value is this. And then for R equal to negative 1/2, second scenario, sum to infinity will be A over 1 minus R. A is already 10. 1 minus of minus 1 by 2 gives you 3 over 2. 2 goes up, so this becomes 20 over 3. All right. So these are the two possible answers we got for the sum to infinity for two values of R, that is positive half and negative half. Okay. So this is what the question was all about. Now, coming on to the seventh question from radian measures, finding the area, I guess. Yeah. Okay, so let's read this question. The diagram shows a metal plate A, B, C, D, E, F consisting of 5 parts. So we have 1, 2, 3, 4, 5. Okay. The parts B, C, D. So where do we have? Okay, this part B, C, D and D, E, F are semicircles. Okay, so they are basically identical. Okay, because the angle opposite to them is theta and the sides are 20, 20. So BD and FD, these two are basically the diameter of these semicircles, and these sides are, opposite to the equal angles, isn't it? So the side opposite to equal angles have to be equal. So BD is basically equal to DF. That's what they meant here. Now the part BAFO. So where do we have BAFO? That's a sector, okay, of a circle with center O, and the radius is 20 centimeters. Perfect. And D lies on this. So D lies on this. So what they're trying to say here is, if I complete the circle over here, something sort of this. So D lies on the circle. Okay, this is what they're trying to say here. All right, so far so good. Now the parts OBD, okay, and ODF are the triangles. Make sense? Angles BOD, and thus both are theta radians. Okay, so this is what we have. Now it's given to us for the first bit, given that theta is equal to 1.2 in radians, find the area of the plate, give your answer correct to 3 significant figures. All right, so theta is given to us. Now we have to compute the area. So let's do this bit by bit. So here this theta is 1.2, here also it's 1.2. Okay, so now let me mark these points. This is part 1, this is part 2, this is part 3, and this triangle is 4, and this triangle is 5. So total 5 regions we have, and we have to find the area of individual things. So what will be the area of this sector? Area is basically half times r square theta. Okay, so what is the angle for this? Wouldn't it be this one? So 1.2 plus 1.2 is 2.4, and the complete radiance is how much? 2 pi inside the circle. So this will be 2 pi minus 2.4. Okay, so this is for this one. So we get half times r is 20. So 20 squared times 2 pi minus 2.4. All right, so we get 200. 20 square is 400. 400 by 2 is 20. 200. That's 2 pi minus 2.4. All right, so we got this. Now, what I need to do, I need to find the area of these two triangles, right? So area of the two triangles would be half times area of the triangle I'm talking about. Two given sides, that's 20 times 20 times sine of the angle enclosed by these two. Okay, so this becomes again 200 times sine of 1.2. So using calculator, you can, change the menu or the mode, you can say, to radians. All right, don't put it as degrees because here the input is 1.2 radians. So keep that in mind. Otherwise, you will go wrong. Or else you could convert this 1.2. So basically this value, now let me do this in the calculator. So this roughly would be, how much we're getting. Okay, there are two triangles, right? So I'll just multiply it by 2. Okay, let me write it clearly. There are two identical triangles. So I'll just multiply this result by 2. Okay, so 2 multiplied by 20 times 20 is 400. 400 by 2 and 2. So this becomes 200 times sine of 1.2 radians. Okay, so this becomes 400 times sine of 1.2, which is, I'm talking about the area of the two triangles. So which is nothing but, finally we get 776 point, or sorry, this is not 776. You will get it as 372.8156. Got it? So this is what we got. And this value in the calculator, if you'll do, the area of the sector is, and this is the second one, this is the first one. So this is 7 to 6 minus 4, 4 times this. Yeah, this will be 776.6372, something sort of this. So one is this, one is this. And now I need to compute the value of these two semicircles, right? So for that, I need the radius of these two circles. So how do I do that? So in order to find the radius, I need to first find what is the radius over here, right? This R value, or you can say the D value. So using this triangle, which is BOD given to us, okay, we know the angle it is 1.2, so I can use cosine rule. I know BO, I know OD, so I need to find BD. So BD square will be using cosine rule. Okay, because I need to find the area. If I know the BD, the diameter of one, then I can use the area of a circle, because the semicircle, both the semicircles added together will give me a complete circle. So 20 square plus 20 square minus 2 times 20 times 20 times cos of 1.2. All right. So from here we get BD square is equal to 800 minus 800 cos of 1.2. So we get BD as under root of this value. Okay. So BD square. Now BD square is what? BD is basically the diameter, isn't it? Since BD is the diameter of semicircle, so what will be the area of the semicircle? This plus this. Now BD, since BD is equal to DF by symmetry, okay, these two semicircles are equal, and therefore I can say the area of the semicircle plus that semicircle will be equal to pi r square. Okay, now what is radius? Isn't it dia by 2 whole square? So that becomes what? Pi d square by 4. So this value, if you plug in, BD square value is this basically. So you just solve it and put it over here. So final answer, you will get it as 400.321. Okay, centimeter square. So now all I need to do is just add them. So the first thing I got 776.6372. And this is the net area of the entire figure. I hope you understood how I've done this. Plus 400.321 plus 372.8156. So if I'll add them together, I basically get 155. Okay, 1549 something. So they have asked us to, convert it to three significant figures. So that will be, if you round it off, you will get 1550 centimeters square. All right. Yeah. So this is what I need to do in this particular question. I hope it is clear to you. Okay. Yeah. So this angle we found by subtracting from 360 minus this. All right. And here the radiance is 1.2. So when you are plugging here, sine of 1.2, make sure the calculator, the menu is decided for radians. You convert that into radians and then go ahead with the calculation. All right, so it makes sense. Now, next bit is given instead that the area of each semicircle is this. So let me draw the semicircle over here. So it's something sort of this, and a rough sketch. That's theta, that's 20, that's 20. Okay. And then one more semicircle was here. So I'm drawing a rough sketch. This was also theta, this is also 20. So area of this is given to us. So how do we proceed now? So area of semicircle is how much? Half times r square times pi, right? So this is what is given to us as 50 pi. So pi and pi cancels out. So we get the radius square is equal to 100 or r is equal to 10 centimeters. Since r cannot be negative, so we get r as 10 centimeters. So this is important. So that means the radius is 10. So dia is 20. Here also the radius would be 10 and here also it will be 10. Okay, perfect. Now we have to find the exact perimeter of the metal plate. All right. So now one thing is important. In order to find the complete thing, we have to find the arc length, isn't it? So complete arc length BF. So let me put it like this shape. So here we need to find this L, this length L, and this length L. Okay. And then we need to add them up. So that is the entire parameter. This perimeter. Okay, what else we need to find? That's all right. Perfect, perfect. So now, what is the angle? Okay, don't assume that theta is still 1.2. If you assume this, it will be wrong. Okay, because it is given that. The question says over here, given instead that the area of each semicircle is this, right? So I need to find theta is not given. In the previous case, it is given that, right? So whenever the question says given that, so for this particular value of theta, you need to find. All right. So this is a catch over here. So let me highlight this. Whenever given is mentioned, you have to find new theta corresponding to r equal to 10 centimeter. All right. So let's see how do we do that. So I'm given with this triangle like this. That's theta and that's 10 radius and this is 20. So if I drop a perpendicular, right, like this. Now this is an isosceles triangle. Why is it an isosceles triangle? Because over here, what do we get? That's theta, right? So it will be half of this, isn't it? So since this is 20, this is 20. So this triangle basically is an isosceles triangle. Right? Two sides are 20. It's an isosceles. So I know that from where. So let me draw it correctly. Upside down so that it will be more clear. So now I could say this is how the triangle looks like. That's theta. This is some O. And that's 10 centimeter. That's 20 centimeters. If I draw a perpendicular from this, okay, like this. So that will be theta by 2, isn't it? So that would be theta by 2. So how do we compute this theta? That is what we need to find. Okay. So in order to find this theta, opposite is given, we can say, and hypotenuse is given because this is 90 degrees. And we know that if I drop a perpendicular, it's an isosceles triangle. So it will bisect this angle as well, right? So for an isosceles triangle, this was also 20 centimeters. The vertex from which, this altitude is drawn, it is equal to median as well. Right? So if I name it as M and this as N, so in triangle ONM, using trigonometry, I can say sine of theta by 2 should be equal to opposite over hypotenuse. So we get sine of theta over 2, which is nothing but 1 over 2. And we know that sine 30 is 1 over 2. Are you getting this? So we get theta by 2 is equal to 30, which is pi over 6. Isn't it? Perfect. So what will be theta from here? It will be 2 pi over 6, which is nothing but pi over 3. Okay, so that means theta over here, we are getting it as 60 degrees. Okay, so we have r and we have theta as well. Okay, so let's put it over here. So this is pi and this is also pi over 3. So that completely would be pi over 3 and this is also pi over 3. Okay, so now let me redraw the shape over here. There's something sort of this, does this, and this entire length. Okay, so this is pi over 3 and this is also pi over 3 we got by symmetry. So what will be this length? Let me take this angle. So this will be 2 pi minus 2 pi over 3. This will be that angle. Now we know that the radius is, here the radius is 10. Here also the radius is 10. For the larger one, it is 20. So this is L1, and this is L2, and this is L3. So arc length L1 is equal to r theta. So r is 20 times 2 pi minus 2 pi over 3. This turns out to be 20 times LCM is 6 pi minus 2 pi, which is 4 pi over 3. So that turns out to be 80 pi over 3. Okay. And then I need to find arc L2, which is again r theta. Okay. So L2 plus L3 is basically a complete circle. So a complete circle is nothing but 2 pi r. So this becomes 20 pi. Okay. So I need to add them together. So final answer is 80 pi over 3 plus 20 pi, which becomes 140, right? 3 times 20 is 60. 60 plus 80 is 140 pi over 3 centimeters. So that is your answer for this one. Okay, I hope it is clear. Since these two semicircles are identical, so if I'll add them, the perimeter is what? The outer length, right? The circumference of the circle of these two semicircles, if I add them. Perfect. Okay, now moving on to the next 8th question. So it's given that express this entire quadratic expression in the form of sum squared, where, ABC, AB are the constants to be found. Okay, so completing the square method, we have to follow over here. So I had told you the first thing is to make the coefficient of x square as 1. So take 3 outside, you get negative, and then over 3 plus 14 over 3. All right. So if you simplify this, you'll get x square minus 4x plus 14 over 3. Now, x square minus 4x, how do you complete the square for this? So let me use a different color. So x squared minus px form can be written as x minus p by 2. So 4 over 2 was 2. Complete thing squared and put brackets 3 outside, minus p over 2 whole square. So p over 2 was, p value is 4. So 4 by 2 is 2, and it's a square, and minus is outside. Okay. And the remaining constant as it is, 14 over 3. So now you just take this 3 inside. So you get it as 3 times x minus 2 whole squared minus 3 times 4 plus 14. 14 over 3 times 3 is 14 itself. So you get finally 3 times x minus 2 whole squared minus 12 plus 14. And that turns out to be 3 times x minus 2 whole squared plus 2. Okay, so that is your final answer. All right, perfect. Now next thing is the function f of x is equal to, this is defined for x greater than or equal to k, where k is a constant. Okay, so now find the least value of k for which the function is this. Okay, so I know that here. So how do you answer this? You could answer this by using either the graph or using this algebra, the function itself. So we know that the coefficient of x square is positive, right? So it will be a parabola opening upwards, and its vertex is 2, 2, isn't it? So its vertex is 2, 2. And if I put it on the number line, the graph, right? So when the f inverse will exist, when we restrict the domain, and it is given that x is greater than or equal to. So this is the axis of symmetry, right? AOS. So on the right hand side, so x should be greater than or equal to 2, for which it should be 1, 1. Right? If I do horizontal line test, it will fail, right? If I take both. So I should restrict it till here, only this green part. Okay, it should be 1, 1. See, everywhere it should strike only once. So x should be greater than or equal to 2. How do I get the vertex? Put here x minus 2 equal to 0. Okay, so you get x equal to 2. So when x is equal to 2, this part is 0, and you get the constant at this. So this is basically called as the vertex form of the quadratic. Okay, so x equal to 2 plus this constant gives you the vertex of the parabola over here. So x should be greater than or equal to k. So k here should be 2. Then only the inverse is defined. Okay, if this would have been lesser than, then also lesser than 2. Okay, fine. Now they're asking for the rest of this question. You should assume that k has the value found in part B. Okay, so that means x is greater than or equal to 2. Find an expression for f inverse of x, right? So whenever inverse is there, I have told you two things to remember, right? The domain. So it is defined for x greater than or equal to k. So what is the domain? Domain is this. Okay. So for inverse, if this, what will be the range? This domain will become the range for the inverse. So this is what the concept is. So what will be the range of f inverse of x? Range is f of x greater than or equal to 2. That means it should be positive. So now assuming the equation y equal to 3 times x minus 2 whole squared plus 2. Now interchange the variables, becomes y minus 2 whole square plus 2. And then now make y as a subject, so you get x minus 2 over 3 is equal to y minus 2 whole square. Taking the square root outside, x minus 2 over 3 plus or minus equal to y minus 2. And this becomes 2 plus minus equal to y, and this y becomes f inverse of x. Now we get plus and minus, right? So now how do I decide whether it should be plus or minus? So I clearly see that the domain of f of x becomes the range of f inverse of this. So range is positive, right? Greater than or equal to 2. So when this will be positive? When I take it as positive. 2 plus x minus root 2 over 3. Because under root is always a positive quantity. So that is the expression for f inverse of x. So let me underline this. Got it? So this is how we decide basically. The domain will become the range and the range of f of x. So range is what? Basically f of x greater than equal to 2. Right? So that will become the domain. And that is legible also. Yeah. X should be greater than equal to 2. Then only it will be greater than 0, right? Perfect. Now, D part is hence or otherwise solve the equation. So how do you solve it? Don't do here the, what do you call? The combine functions. Okay, don't do f of x equal to 29, make a quadratic complex thing. No. So how do we proceed here? We just take f of x is equal to f inverse of 29. All right. So what is inverse function? F inverse is 2 plus under root x minus 20, x minus 2 over this. So that's 2 plus under root x minus 2. So x is 29 minus 2 over 3. So that's your f of x. Okay. Equal to 2 plus 27 over 3, which is 9. So 2 plus square root of 9, which is positive 3. So we get this thing as 5. All right. So f of x, we got it as 5. And now I need to solve the equation, means find the value of x. So again, do f inverse of 5. Take this f here. So f inverse of 5. So f inverse of 5 would be 2 plus again x minus 2, x is 5, minus 2 over 3. So that's 3 over 3, which is basically 1. 3 over 3. So you get 2 plus under root 1, which is equal to 3. So x equal to 3 is the right answer. Okay. Does that make sense? Perfect. All right. Now, so moving on to the next one. All right. It belongs to the point of intersection. Okay. So, all right. Now, two equations are given to us. We need to find the point of intersection. So, point of intersection concept is what? We just equate these two functions, isn't it? This is one point and this is another point. Let's name this as A and B and equate them. So, we get x cubed minus 3x squared plus 3 is equal to 2x cubed minus 4x squared plus 3. All right. Whenever you need to find the point of intersection, always equate the two equations given to us. All right, so like taking the like terms to one side, 2x cubed minus x cubed minus 4x squared, 3 and 3 cancels out, and then we have plus 3x equal to 0. So we finally get x cubed minus 4x squared plus 3x equal to 0. I can take x common, so we'll get x squared minus 4x plus 3 equal to 0. Therefore, we get x equal to 0, or x squared minus 4x plus 3 equal to 0. So two numbers whose product is 3 and the difference is 4 is basically 3 and 1, right? So x minus 3 times x minus 1 equal to 0. Therefore, we get x equal to 1 or 3. So the point of intersection is basically this, right? So that's 0 over here. And we have to find the only the x coordinates. Perfect. So my final answer is x equal to 0, 1, and 3. Okay. And let's see whether this makes sense or not. Yes. So this is 1 comma y, and this is 3 comma y. Okay, so we got x is equal to 0, 1, 3. Now moving on to the next one, we have find the area of the shaded region. So for shaded region, I need these points. Okay, so here, if I'll see, the value of a goes from 1 to b, right? These are the values of x. So we need to integrate from 1 to 3. And how do I get this area between the curves? It's always upper minus lower, right? So 1 to 3, and the area becomes integral of the upper curve minus the lower curve. So upper curve is x cubed minus 3x plus 3. So the required area is from negative 1, sorry, that's positive 1. Positive 1 to 3. So you get x cubed minus 3x plus 3. All right, minus, we get 2x cubed minus 4x squared plus 3. Okay, so let me recheck this. Minus 4x squared plus 3. Perfect. So upper curve minus lower curve from 1 to 3. This is what I need to integrate for the area between the curves. So if I'll open this, I'll basically get negative x cubed minus 3x minus times minus is plus positive 4x squared plus 3 and minus 3 cancels out. So this is what is the expression for the area from 1 to 3 dx. Now I need to integrate this. So I'll get negative x4, positive 4, negative 3x2 over 2 plus positive 4 over 3 x to the power 3 under the limits 1 to 3. So now integrating it further, we get upper limit, that is negative 3 to the power 4 over 4, negative 3 times 3 squared over 2 plus 4 over 3, 3 cubed. So that's upper limit minus lower limit, that's negative 1 by 4, negative 3 by 2, and positive 4 by 3. So now solving it further, we get negative 81 over 4, negative 27 over 2, plus 36 minus times minus is plus. Let me open this bracket. Plus 3 over 2 minus 4 over 3. So we get it from here as negative 81 over 4 plus 1 over 4, negative 27 plus 3 over 2 plus 36 minus 4 over 3. So this becomes negative 80 over 4. And that's it. This becomes negative 24 over 2 plus 36 minus 4 over 3. And once you solve this, you get negative 20, negative 12 plus 36 minus 4 over 3. And then solving it further, you get negative 32 plus 36 minus 4 over 3. And therefore you get a equal to 4 minus 4 over 3. Now taking the LCM of Coran this. So you get 12 minus 4, complete thing over 3. And therefore, we end up with the final answer as 8 over 3 square units. Okay. So this is what the answer is for this bit. So we have to find the area, and area between the curves, you know that it is always the upper bound minus the lower curve, to be precise. All right. Now let's see the 10th question. It says 2 points are there. A and B have coordinates 4, 3 and 8, -5 respectively. A circle with radius 10 centimeters passes through the points A and B. Show that the center of the circle lies on the line y equal to x over 2 minus 4. Okay, so let's get a rough sense of it. So we are given with a circle. All right, and there are 2 points. So let's consider them as A and B. So that's A and that's B. Coordinates of A is 4, 3, and coordinates of B is 8 and -5. Whenever you get these type of questions, draw a rough sketch always. And there is a center, okay, which we don't know. And let's consider the center to be x comma y, right? So if I join this AB, this becomes a chord basically, right? So AB is a chord. Okay, so far we know this much. And then they are saying is that the radius is 10 centimeters, right? So R is also given to us as 10 centimeters or 10 units basically. Show that the center of the circle lies on the line. So I need to find the equation for the center, right? So how I can do this? So one way to think is using IGCSE or the law, which theorems which we have learned, right, of circles. So one of the circle theorem says, if I have a chord, right, then if I have a line that passes through the circle, okay, that will be perpendicular to this. Okay, and it will be perpendicular to it, and it will also bisect it. Getting it? So using circle theorem, I could say line passing through O through center, that's x comma y, which we had assumed, right? And let's say right here the center is x comma y for this particular circle. So line passing through the center and bisects the chord. This is what the theorem is. Bisects the chord AB. So bisecting the chord AB means what? Can I say this point, if I assume it to be C, then C will be the midpoint, isn't it? Because any line that is perpendicular to the chord and it passes through the center, that means it will bisect the chord. Therefore, C is the midpoint of AB, right? So finding the coordinates of C, we get 4 plus 8 over 2, comma 3 minus 5 over 2, right? So what are the coordinates of C? We get it as 6, comma -1. All right, so that's 6, comma -1, the coordinates of C. Perfect. So this is what we have. Let me remove the sign and this one as well. So we got C, and now I need to find the equation of this line, right? So can you simply say if they're perpendicular, right? The center, basically over here, the center is perpendicular, right? OC is perpendicular to this. So let's quickly find what is the slope of AB. So slope of AB is y2 minus y1 over x2 minus x1, which is -5 minus 3 over 8 minus 4. That turns out to be -8 over 4. That turns out to be -2. So the slope of line AB is this. So what will be the slope of a line that is perpendicular to it? Slope of the line OC, the required line, let it be OC, a part of it, that will be negative reciprocal of -2, which turns out to be positive. Right, so I know the slope of the line, and therefore the equation would be y equal to mx plus c. Okay, and I know that it passes through 6, comma -1, and that is the point C. Right, so I have a point and I have a slope as well. So how do I do this? So we get y equal to 1 over 2x plus C, and just plug in this point, -1, 6/2, and therefore we get C equal to -1, -3. So C is equal to -4. All right. So therefore our final answer y equal to positive half x minus 4, and that is what is required over here. Okay, so how do we find the equation of any line which is perpendicular to other one? We find the slope of the given line, which was the chord AB, and then the slope of OC will be what? Negative reciprocal of it, and we found C is the midpoint using the circle theorem. Okay, so this was a nice question. Now they're asking, find the two possible equations of the circle, right? So that's the next question. So in general, what is the equation of a circle? Isn't it x minus a whole squared plus y minus b whole squared is equal to r squared? Now what is given to us? Given to us is r, which is equal to 10. And just now we have seen, let me put it here, that we got the equation of the circle which is passing through 1 by 2x minus 4. And if I assume that the center is a comma b, right? So let the center be a comma b. Therefore, how a and b are related to each other? And it also passes through a point a and this point b. There are 2 points as well, right? So that's 4 comma 3 and that's 8 comma -5. Am I correct? So it's given that the circle passes through these 2 points as well. Okay, perfect. So now we need to find the center. Let center be a comma b, and the general equation of the circle is this one. And therefore, it also passes through 4 comma 3. Any one point you could take, right? So therefore, I can plug in x value is 4. This circle will satisfy the equation, okay, of this, and the point will also satisfy minus a whole squared plus y is 3 minus b whole squared is equal to 10 squared. This is what we have. Now, I have two unknowns. So what is the relation between a and b? I know that a and b satisfy this equation, right? The equation of the line which basically passes through the center. So can I simply use this so that this line passes through the center, right? Therefore, y is b, a is x minus 4. So can I say using the line equation which we found, and by this line, the center also passes through this line. So I could plug in the coordinates of center here, and therefore I get b in terms of a, right? The y coordinate of the center is this. So putting this in the equation of the circle, b value over here. So we get 4 minus a whole squared plus 3 minus a over 2, and minus times minus becomes plus 4 whole squared is equal to 100. Right, so b value I'm substituting it from here. I hope you can get this. So now opening the brackets, I get 4 squared is 16 plus a squared minus 8a plus 3 plus 4 is basically 7. So that's 7 minus a over 2 whole squared. Okay, so let me open this here a bit down. So we get 16 plus a squared minus 2ab plus 7 squared is 49 plus a over 2 square is a square over 4 minus 7a. 2ab, 2 and 2 cancels out, so 7a with a negative sign equal to 100. Perfect. Now, adding the like terms, so we get a squared plus a square over 4. 49 plus 16 is 55, 65. And thus becomes negative 15a. Negative 8a and negative 7a. This becomes positive 65 equal to 100. Okay. So now this becomes 5a squared over 4 minus 15a minus 65. 100 comes here. So we'll get 35 equal to 0. Multiplying throughout by 4. we get 5a squared minus 15 times 4 is 60a minus 35 times this is 140 equal to 0. Okay, now taking 5 common, we get a squared minus 12a minus 28 equal to 0, or we get a squared minus 12a minus 28 equal to 0. So from here, two numbers whose product is 28 and negative 28, and the sum is also negative 12. So that's negative 14 and 2, right? Negative 14 plus 2 equal to 0, and therefore we get a equal to 14, or we get a equal to negative 2. Got it? So now we have a, now what is b? B is equal to a over 2 minus 4. Therefore, 14 by 2 minus 4, and therefore we get b value as 7 minus 4, which is equal to 3. And from here we get b equal to negative 2 over 2 minus 4, therefore b equal to negative 5, right? So the two equations what we get is x minus a, when a is 14 and a is negative 2, b is 3 and b is negative 5. Okay, so one set we'll get for this. So we get x minus 14 whole square plus y minus 3 whole square is equal to 10. And the second equation is x plus 2 whole square plus y plus 5 whole square equal to 10. So these are the two solutions which we need to get. All right. So I hope it is clear to you. Perfect. Now moving on to the last question, which is the 11th one. So let's see this. It's from differentiation. So it says the equation of a curve is y equal to kx times to the power 1 by 2 minus 4x squared plus 2, where k is a constant that's given to us. And we need to figure out what is dy by dx and d2y over dx squared. So first derivative and the second derivative. All right. So finding the first derivative, k is a constant, so it will remain as it is. X power 1 by 2, so differentiate the power, and root x will come down. Negative 8x, and the derivative of 2 is 0. Right? 2 times 4 times x. So that's dy by dx. Now the second derivative of this, so that becomes negative. K is a constant, power is 1 by 2, so this becomes 4 times x to the power 3 by 2 minus 8. Okay, so this is what is the answer for the second derivative. All right, so you might be thinking how I've written. Basically, I've used the trick of 1 by under root x. So how do I differentiate this? This is positive, so change the sign. Okay, then what is the coefficient of, the power of x? It's 1 by 2. So you multiply the power with 1. So 1 times negative 1 by 2 is 1 by 2 itself, and you increase the power by 1. So 1 by 2 plus 1 is what? That is x to the power 3 by 2. And that is how you get this. All right. So I've explained you all these things in my videos, so you can check those out. How to differentiate 1 by x. There are super easy tricks which you can do within seconds. Now it is given that k is equal to 2. Find the coordinates of the stationary point and determine its nature. Right. So k is equal to 2. Okay. So what is my dy by dx? Let's find that first. For k equal to 2. It turns out to be 2 over 2 times root x minus 8x, which is nothing but 1 over root x minus 8x, right? And at stationary point, we know that dy over dx is basically equal to 0, right? So therefore, equating 1 over root x minus 8x equal to 0. So what do we get from here? We get basically 1 over 8 is equal to x times root x. Here. So we get 1 over 8 is equal to x to the power 3 by 2. And this is actually 2 to the negative 3, x to the power 3 by 2. Now squaring both the sides, you get 2 power minus 6 equal to x cubed. And now taking under root, cube root both the sides, so that will become 1/3 power, which is equal to x. or we get x is equal to 2 to the negative 2, which is nothing but 1 over 2 square, which is x equal to 1 over 4. So we get the x as 1 over 4. Now I need to find the second derivative, d2y by dx squared at k equal to 2, and the point is x equal to 1 by 4. So second derivative is negative k is 2, for x to the power 3 by 2 minus 8, isn't it? So we have it as minus 8, and therefore it becomes negative 1 over 2x to the power 3 by 2 minus 8. So that's the second derivative we have at k equal to 2. Now I need to check for x equal to 1 by 4. So the second derivative minus 1 over 2 times 1 over 4 to 3 by 2 minus 8, which is basically 1 by 2, 1 by 8. So that's negative 12, which is actually lesser than 0. And therefore, x equal to 1 by 4 is a maximum. Okay, it's a maxima. And the point at x equal to 1 by 4 will get y value, and that will be the maximum point. Okay, so this is what we need to do over here. Perfect. Now, coming on to the C part, it says points A and B on the curve have x coordinate as 0.25 and 1 respectively for a different value of k. All right. The tangents to the curve at the point A and B meet at a point with x coordinate 0.6. So whenever the situation, the given constraints are complex, always get a rough idea by drawing a rough sketch. So let's assume that this is how some curve it looks like. Here we have A, and this point is B, and the x coordinate of A is 0.25, which is 1 by 4, and B is 1. So I could find the y value. And there are tangents drawn at this point and this point, right? So they meet at this point whose x coordinate is 0.6. So I can say this is tangent 1, and I could say this is tangent 2. All right. So this is what we know. Now we have to complete A and B. So since A and B, they lie on the curve. So they basically lie on the curve. Therefore, y coordinate of A would be how much? So for A, x is 1 by 4. So I need to find y value. So y is equal to, let's see what is y. Y is k root x minus 4x squared plus 2. Right? So that is k root x minus 4x squared plus 2. And therefore, at x equal to 1 by 4, we get under root 1 by 4 minus 4 times 1 by 4 whole square plus 2. And therefore, we get the y value as k over 2 minus 4 square is 16, and then 4 over 16 is 1 by 4 plus 2 itself. So which basically gives us k over 2 and negative 7 over 4. Right. So this is our y value. Well, let me check it once more. 4x squared plus 2. Right. Okay, perfect. So this is what we get the y as. So let me write it nicely. Should it be plus? Yeah, this should be plus, right? 8 over this. So I can write this thing as k by 2 plus 7 over 4 is 1.75, right? So A is here 1.75. So we got the value of A. Okay, we'll go slowly. So we got the coordinates of A, that is 1, 4 and 1.75, right? So this is 1.75. So first thing is to find point A and B. So now let's do for B. So let me put a line here. So for B, we got the y coordinates. Okay. Now for B, x coordinate is 1. So now I need to figure out y. So k times under root of 1, negative 4, 1 squared plus 2. So we get y as k minus 2, right? Perfect. So k minus 2. So we got B also. The coordinates of B is 1 comma k minus 2. Now why we are doing this is because clearly from the diagram I can say that T1 and T2 are two tangents and they intersect at a point whose x coordinate is 0.6, and we need to find the value of k. So that means I need to find the equations of T1 and T2, isn't it? So now I need to find what is the slope of tangent T1. Okay, so that's at A. So let me do that with a different color. So slope of at A, what do we have? The tangent T1, right? At point A, T1. Slope of T1 is basically dy by dx at x equal to 1 by 4. At x equal to 1 by 4. So what is dy by dx? We have found in the previous question itself, which is k over 2 root x minus 8x. K over 2 root x. K over 2 root x, x is 1 by 4 minus 8x. X is 1 by 4. Perfect. So we get the slope m of T1, which is 1 by 4 means 1 by 2. So we get k minus 2. Perfect. So we got the slope and we know the point. So therefore, the equation of T1 would be what? It will be y is equal to mx plus c. All right. So we know the slope and the point is what? The point is a, which is nothing but 1 over 4, comma k by 2 plus 1.75. This is the point at which the tangent T1 is. Right. So we have this point A, which is 1 by 4, comma 1.75. So I know the slope and 1 point, so I can find the equation. So y equal to mx k minus 2 times x plus c. And now finding the value of c, I could quickly write when y is k plus 2 plus 1.75, we have k minus 2, x is 1 by 4 plus c. So we get it as k by 2 plus 1.75 equal to k over 4 minus 1 over 2 plus c. Therefore, we get c is equal to k by 2 minus k by 4 plus 1.75 plus 1 over 2. Okay. So this is what we get. Now, what we have is c is equal to k over 4 plus 1.75 plus 0.5 will eventually give you 2.25, right? So that's c value. So we got the value of c, and therefore the final equation, we get y is equal to k minus 2x plus c is k by 4 plus 2.25. All right, so this is the equation of the tangent T1. All right, perfect. So let me do here now. The slope, let's find the slope over here for this. Let me use the brown color itself. Slope of T2. So slope of T2 would be, so we got this k minus 2. So dy by dx and at x equal to 1. So that is how much? Dy by dx value is 2, it's k over 2 root x minus 8x. So k over 2 root x means under root of 1. Okay, so let me erase this bit. Minus 8x, 8 times 1 is this. So we get k by 2 minus 8. So this is the slope we have for the tangent 2. And now finding the equation y equal to mx plus c. So we know the point is 1 comma k minus 2. So slope is basically k minus 2 minus 8 x plus c. Now the point is how much? K minus 2, 1 comma k minus 2. Perfect. So when y is k minus 2, x is 1. So we get k minus 2 minus 8 plus c. And therefore c value is k minus k by 2 minus 2 plus 8. So how much do we get? We get k by 2 plus 6. So that's c. And therefore the equation of the tangent T2 is y equal to k by 2 minus 8 multiplied by x plus k by 2 plus 6, right? Now we have the point of intersection. So point of intersection, the x coordinate is 0.6, and we have to find the value of k. So just equate them. We get k by 2 minus 8 times at x equal to 0.6. So the equation of T2 and the equation of T1, you just equate them. So T1 equal to T2 at point of intersection, and the x coordinate is 0.6 plus k by 2 plus 6 equal to k minus 2 multiplied by 0.6 plus k by 4 plus 2.25. Okay, so solving this further, we get 0.3k minus 4.8 plus 0.5k plus 6 equal to 0.6k minus 1.2 plus 0.25k plus 2.25, right? This is how you will get this. And then once you solve this, right? So in terms of k, you'll get this equation, which is something like 0.15 is equal to 0.05k, and therefore you get k equal to 0.15 over 0.05, which is nothing but 3. So you get the value of k as 3. Okay, so the concept was simple, only the working is a bit challenging. That's the reason it is for 6 marks. So A and B points are given. So find the coordinates by plugging in the value of x, okay, in the equation of y. So we got points A and B, and then finding the slope at those 2 points. And then we found the equation of the tangents at those 2 points. And then we equated the equation of the tangents to get the value of k at x equal to 0.6. Okay. So I hope you learned something new and all your doubts were cleared. So do subscribe my channel and share with your friends. Thanks for watching.